Hello everyone, we're going to be talking about adding and subtracting radicals today. The first thing I want to make sure that we are making each of our solutions and we are stating that they are either rational or irrational. So the same rules actually apply to combining like terms, so I'm going to go ahead and show you a couple combining like term problems just to refresh our memory. So if we have 4y minus 2x plus y plus 5x, then we go through and combine our like terms. We have to have the same letter, and then we have to have the same exponent. So this has a y as an exponent of 1, and same with that. So there's 4 plus my 5, or 4 plus y, 4y plus y is 5y. Then we have our other term here, which is our x values, and they both have an exponent of 1, so they are the same term there. We have a negative 2x and a 5x, which we have positive 3x then. And then we just want to make sure that we write that in standard form, which means that we always have our alphabetical order. So our solution here would be 3x plus 5y. And that was our combining like terms, which means that the same rule actually applies for our radicals. So if we have our square root of 3, plus 2 square root 7 minus 4 square root 3 and then plus square root 7. So we almost want to have the radicals be identified as the variables like in our first example up here. And then we still have our coefficients, the numbers in front of the radical. So I'm going to go ahead and I'm going to combine my like terms like I just did with the previous example. So I see that I have a cubed root of 3 here and a cubed root of 3 here. The first one I had a positive 9, second one I have a negative 4. So we have a positive 5 root 3. Now I'm going to go ahead and go to my my root 7s, which is the separate, very technically combined like terms. I have 2 here. There's an invisible 1 on this root 7, so 2 plus 1 is 3. And you just keep the radical just like we did on the variables up here for the x's and y's. So we now then get to do our radicands that are not identical don't get to be combined just like our actual values of when we're combining like terms. So let me just give you an example like this. So 2 root 7 plus 3. If we have like a cubed root 7, we actually are not allowed to do a cubed root and a square root together. So our final answer is just going to be the 2 square root 7 plus 3 cubed root of 7. So you cannot combine a cubed root with a square root, and that is our final solution. Now we're going to go over the steps to simplifying radicals with addition and subtraction. So our first step, we're going to simplify the radical completely. Then you want to find the roots, which is by taking the square root or cubed root or nth root, however high the root is going to go. Then we're going to combine like terms, the ones we're able to, and we need to state that the solution is irrational or rational. Remember that irrational means that we have a radical left over. Rational means that we actually have a whole number or a non-repeating decimal. So for our first example here, we're going to start off with the basic example. So I have the square root of 12 plus the square root of 3. Our first step, it says to simplify the radicals completely. So we're going to take each one, we're going to simplify it. So 12 gets broken down to 4 and 3. And I'm going to stop here because I know the square root of 4 is 2. So I know that my new radical reads 2 root 3. You guys are welcome to break them down again if you don't see that, but the square root of 4 is 2. So then my other one, I can't break that 3 down, so it stays left as square root 3. So now my second step is we already found the roots by breaking those down. It's called simplifying. And then we're going to combine our like radicals. So this has a radical 3, this also has a radical 3, this has a coefficient of a 1. So 2 plus 1 is 3, radical 3. We are unable to simplify our radical anymore, so that's our final answer. And since we have a radical we actually have a radical left over, this solution is irrational. For our example 2, I'm going to go ahead and throw in some variables in there too. So we have 2 square root 18x plus 3 times the square root of 8a minus 50. Okay, so we have our 2 square root 18x plus 3 square root 8a minus the square root of 50a plus the square root of 40a, and actually I meant to say x's on all these. So 4, I had to rewrite my problem because I ran out of room. So this was a 50x, x, and an x. So you should have x's for all of them. Okay, so our first step, we are going to simplify each of these radicals. I know that the perfect square is 9, so the square root of 9 is a 3. So I now have 2 times 3, and then I have a radical with a 2 and an x. Now I'm going to go ahead and simplify this completely. 3 times 2 is 6. The square root of 2x stays the same. Now I'm going to go ahead and simplify this one. I know my perfect square is 4, so the perfect square of 4 is 2. So we're going to bring down that plus sign. Then we have 3 times 2, and then we don't have any x's or other 2's that can come out, so this is just 2x. Now I'm going to bring down my minus sign, and then we're going to break down the 50, and we're going to do 25 and 2. Those are my perfect squares, so the 25 is a 5. There's no number I am multiplying out in front of the coefficient there, and I'm left with a 2x inside. And then I'm going to bring down my plus sign, and I'm going to break down my 48, and I see that the perfect square here is 16, and I'm left with 3. So the perfect square of 16, again, if you guys do not see that, you are welcome to use your tree factoring, going all the way down to those prime numbers and still circling the groups. So I still have a 4 out in front of here. That 3 does not get to go out, and neither does the x. Okay, so I've gone through and simplified everything, multiplied by my coefficients on those first 2 terms. I just need to actually simplify this, so I'm going to write this up here. So I have my 3 times 2 square root 2x, so then when I simplify this, now my value is 6 square root 2x. So now I'm going to go ahead and combine like terms. I'm going to work with my 2x's first, so I see I have positive 6 here, positive 6 there, minus 5. So we have our 12 minus 5, which leaves us with our 7 square root 2x. We don't do anything again with those radicands. And then my other one, I see that I have a 3x, but that's the only one that is a 3x, and I don't have any other like terms with that, so I'm going to do 4 square root 3x. And then this is my final solution. I'm unable to simplify the radicands and combine like any terms, which we have an irrational statement here. Okay, so our next example we're going to go over is distribution. So just to show you guys that it's a little bit different, and just to refresh our memory about distribution, we are going to have the square root of 5a times 2 plus the square root of 5a. So when we distribute, we have to multiply this term by all the terms inside the parentheses. So remember, we can only multiply our coefficients, so the coefficient here is 1, and this is outside the radical, so 1 times 2 is 2. And then our radicand stays the same because there's no radical that we are multiplying it by. Now we're going to multiply the square root of 5a times the square root of 5a. So we get 5 times 5, which is 25, and then we also get a times a, which is a squared. Okay, so now I'm going to show you guys 2 different ways to do this. This way we're just distributing. Can't break down that 5a, however, the square root of 25 is 5, so that's going to go out in front, and then the a squared is actually a. So I have nothing left over in my radical, so I'm left with just my 5a. So my final solution, I have 5a plus 2 square root of 5a. You guys can write it this way as well. I just swapped it because this one didn't have the radical, but I would not count this incorrect. So this is our final solution here. I'm okay with either form written, and this is irrational. The other way I wanted to show you guys, so when we go through and distribute, I still no matter what would distribute, so I have 2 square root 5a plus, but the way I wanted to write this was I had square root of 5a squared. Remember that this whole thing in the parentheses, that would actually cancel each other out because they are inverse operations of each other, and then I would be left with my same answer again. So that is also another way. Alright, for our next example, we have a cubed root now. We're going to get a little bit, the last two problems here, we're going to be working with our cubed roots. So I have cubed root of 5x squared plus 7 times the cubed root of 5x squared. So yay, we see that we have cubed roots right here. They're both cubed roots, they're both 5x squareds. So we are allowed to combine these like terms. This is just a 1, so 1 plus 7 is 8. And that means I have cubed root 5x squareds. And that is my final solution for that one. Last example here, you guys, we have a negative cubed root of 8x to the 7 plus 3 cubed root 27x to the 4th power. So we need to break these down first. These are like our, like I said, we'll be working with cubed roots. So I'm going to break down, we are looking for a number that multiplies by itself 3 times. So that's our 2. So the cubed root of 8 is 2. And then we have so I have a negative out in front of here, the 2. We're going to multiply that by how many x's actually get to come out. We get 2, and we are going to have 1 left over that stays inside that cubed root. Then we need to break down this 27. Well, I know that we have actually 3, a group of 3, because the cubed root of 27 is 3. So I'm going to bring down my plus sign, have my 3 out here. We then get to multiply it by another 3, and then we get one group of x's coming out, and we have one group of one x left over. So now I have the cubed root of, oh, I forgot to bring my x out that I just said. So I have one group of x coming out, and I have the cubed root of x left over. I'm going to go ahead and multiply my values here. This one does not actually get rewritten because it's already technically being multiplied. Negative 2x squared cubed root of x plus 3 times 3 is the one I actually wanted to multiply, x to the 3rd power over x. So again, we are only worried about here, the cubed root of x, cubed root of x. We can still combine like terms. However, the thing with cubed roots is that we also have to have the same exponents like we said. Remember, the exponent is a 1 right there, so we are actually unable to combine like terms because our variables in the front do not have the same exponents. So this is an irrational statement again, and I want you guys to pay attention to that we are unable to combine like terms because our exponents as our coefficients, those numbers in front of the radicals, do not have the same exponents. Alright, I will see you guys in class. Have a good day.